Hi, my name is Cassidy Dossin, and I'm the Agriculture and Natural Resources Agent in Clay County. In this virtual presentation, we'll go over soil testing. We'll start off with why it's important and the information you'll get from testing, and then go into how to take your soil samples to send in, and we'll finish off with how to fill out the forms and read your results. So, why is soil testing important? As producers, we want to maximize the yield of our crops and offer the best pasture for our livestock. To do this, we have to start at the ground with the soil. You need to know the current quality of your soil to be able to add fertilizer correctly and efficiently. Soil tests from the U.S. Soils Lab will send you back your soil pH with a lime requirement, along with nutrient levels and information. Using that lime requirement to get your soil pH where it needs to be for your crop ensures that your crop has the best environment to grow, but also fertilizer added in the spring will be better used by the plant when liming is done 6 months prior. Not only are you learning what your soil needs from the soil test, but it's just as important to learn what your soil doesn't need. Producers run the risk of spending more money than they need to and harming the environment by over-applying fertilizer. Getting your soil tested is the easiest way to save money on management and get the most out of your crops and pastures. Have you submitted a soil test for your operation before? Take a second to answer this question before we get started. Now we'll get into the steps for how to collect a soil sample to be sent into the soils lab. Step 1 is to divide your farm into areas for sampling. If you have a large area of the same crop, like multiple pastures of Bahia grass, you can sample these pastures and combine the cores into one sample for submission. Just be sure that these areas have similar soil and fertilizer histories. Once you've decided how you'll split up your farm, start taking the soil samples. Take about 15 soil cores per area or field to be combined into the sample. Make your samples as randomly located as you can, but avoid areas that are too small to be limed or fertilized, and avoid unusual areas, wet spots, feeding areas, and all other problem areas. If you do have a problem area that you want to understand what's going on with, make sure this is a separate sample and label it accordingly. To complete step 2, you have to understand how to properly take a soil core. There's 2 ways to go about it. The first, easiest way is to use a soil tube if you have one. Drive the tube 6 inches into the soil to get your core, and you're done. But if you don't have a soil tube, you can still get the soil cores to make up your sample. Using a shovel or a trowel, dig a 6-inch deep hole into the soil. Slice a 1-inch wide slab off of one edge of this hole and lift it out. Save a 1-inch wide strip of the soil out of the center of the slab, and this will be your core. Moving on to step 3, mix together the cores from one field or area into one sample. Put about a pint of the mixed soil into the sample bag. You can pick up some handy soil sample bags from your extension office to use, but they aren't necessary. Any paper bag or plastic Ziploc will work, as long as you can label it. Which brings us into the final step, which is labeling the sample bag. Whether you use a number or letter system or any mixture of this that works for you, make sure that your labels are different between samples. Keep track of your labels too. Write down the samples you send in so you can easily decipher your results when you get them back. Choosing the right form and filling it out correctly are both important to make sure you get back the results you need. The forms are long and maybe a little intimidating, but we'll go through how to fill them out, and I assure you it's nothing you can't handle. All submission forms can be found and printed on the Soils Lab website, but your extension office will also have them available. For producers, there's 2 main submission forms that you will most likely be using. A producer soil test, which will cover all field crops, forage and pasture crops, and vegetable crops. Everything except for Bahia grass, which is covered by the Bahia producer soil test. All forms will start off with a section to fill out your information so the lab can get your results back to you. Next will be a chart like this one to list your samples. List your sample ID that corresponds to the sample bag, write in your county for each sample, and write in the estimated acreage of the area you're sampling. On the next slide, we'll get into crop codes and test codes. Crop codes are, simply enough, a number that correlates to which crop you're growing on the soil being tested. Choosing the right crop code ensures the soil results are giving you accurate recommendations for your needs. These charts of crop codes can be found on the second page of the producer soil test submission form. So if you have a field you're prepping for cool season legumes, use 22 as the code. Bermuda grass pastures, 25, and so on and so forth. The Bahia producer soil submission form has a much shorter crop code list that can be found on the first page of the submission form. It's pictured here in the bottom right corner of the slide. You will have one of two crops for this form, establishment of new plantings or established Bahia grass. A test code is a number to indicate which test you want done, or what kind of results you want back. This is also where you'll find the price of the tests. The standard soil fertility test, test code 15, is what we typically recommend to get the most information about your soil. You'll get the pH and lime recommendation, as well as macronutrients phosphorus, calcium, potassium, magnesium, and sulfur, and the micros copper, manganese, and zinc. This is the test that will best inform your fertilization plan. But you can also opt to only test for pH and lime, organic matter, and soluble salts if that's what information you're looking for. The Bahia producer soil test codes are listed in the bottom chart and are mostly the same, but there is an extra standard soil fertility test that includes a tissue test. This test does all the same things as the standard fertility test, but also tests a grass sample for phosphorus. In Bahia grass, a tissue sample is the best indicator for how much phosphorus is really needed in the soil. Sometimes a soil tests low in phosphorus, but the grass is able to acquire that nutrient from deeper in the soil, so it doesn't need to be applied as fertilizer. Phosphorus is notorious for causing water quality problems in Florida waterways, so avoiding application of phosphorus where we can is important. You will not get a phosphorus recommendation on Bahia grass without choosing the test code B15 and sending in a tissue sample along with your soil. Next, let's talk about nitrogen. The Bahia producer submission form has an additional N option chart where you'll select a nitrogen level of L, M, H, or He for each of your samples. If we follow the star markers of the chart, we'll find this explanation of how to use the N option chart. It's clearly laid out for us here that we should choose L for normal grazing operations with minimum fertilizer input, M for moderately intensive grazing, H for intensive grazing operations, and He, the highest intensity if we are cutting for hay. The reason we're choosing the type of nitrogen application for our operation is there's no reliable test for measuring nitrogen in the soil. So, the Soils Lab uses research-based information to inform the nitrogen recommendation for each crop. In Bahia grass, we have the luxury of choosing our level of nitrogen input because Bahia grass has shown to respond to different levels of nitrogen fertilization. After you've filled out your submission form, submitted your samples, and waited 5 to 10 business days, your results should be emailed to you. Your county extension agent will get your results in their email as well, so don't hesitate to ask them any questions you might have. The first page of your results will look something like this. Here you can find all the levels of the nutrients in your soil. We can see at the top of the page that this was a Bahia soil sample, and the client labeled this sample as pasture. The first result listed is the pH. The target pH, or desired pH for your crop, is listed as well as the actual pH of your soil. A buffer value is calculated to determine the lime requirement, unless the pH is above the target and no lime is advised, as in this example. Next, we'll find this chart with all of our nutrients listed. Phosphorus, potassium, and magnesium are interpreted as high, medium, or low, while the rest are given in milligrams per kilogram, which is the same thing as parts per million. Don't worry, you won't have to research what all of these numbers mean for fertilizing. If we just go to the next page of our results, we'll find all the answers in the directions, a complete guide for reading and interpreting our results. It's usually several pages long, but if we look through, we'll find specific instructions for the nutrients we're looking for. Here, as an example, is the details on manganese and zinc. Looking at the chart, we need to find our soil pH in the columns and then see if our manganese and zinc levels are above the given ranges. The pH of this soil was given at 6.3, so we can look at the middle column. Our manganese registered at 7.1 parts per million and zinc at 10.0 parts per million. Both of these numbers surpass the ranges given in the chart, so we won't need to worry about adding them to our fertilization plan. If our numbers were below these ranges, we could follow the instructions I've highlighted in the paragraphs. We can find similar instructions for sulfur, copper, and potassium all in the directions section of our results. And finally, the first page of our results ends with lime and fertilizer recommendations. Our pH is higher than desired, so no lime is recommended. This client included a tissue sample with their results, but the soil and grass had adequate phosphorus, so none was recommended. Magnesium, which we can see tested high, also has no recommendation. Nitrogen is recommended at 100 pounds an acre, and this comes from which nitrogen level was chosen on the submission form. We can also go back into the directions section of the results to find a full outline and explanation of the low, medium, high, and hay nitrogen options. Going back into the directions, we'll find that this client chose the medium nitrogen option. If we keep reading through any of the nitrogen option explanations, we'll find the recommendations for phosphorus and potassium at those nitrogen levels. Are you more prepared to interpret and understand your soil results after this presentation? Let us know. Thank you so much for watching, and remember to contact your county agent for any help as you send in your soil samples, read your results, and make a plan for your land.